Hey gang, another toolbox talk. Today is no big deal. We're just going through, we've been really busy building these roller plates, finishing these, another set. They take a lot of time. It's more about the math and center lines and spacing of pulleys and rope path and everything. They just take a lot of time. But we finished this set and we've been making supports for rams at the end, for the cylinder ends. And a lot of you people use these giant four-wheel sleds with a rope clutch on it. And it's like all that weight, all that hassle. We put a simple support on there. It's variable 3mm up and down. We machine them. These are blanks ready to go. I finished the blanks, they're drilled. Now we hand oval these slightly to allow for a 3mm variability up and down because skate wheels are never the same. And sometimes you're not quite flat on your truss. There's a variety of reasons. Nothing we have is standardized. It's nice, but plus or minus a millimeter, plus or minus 2. And if these wheels float, they aren't giving this any support. So what we do is we put them on, we make sure that everything's attached, and we check the float on them, and then we make them variable. So they have a locking screw that goes in the top, and there's a countersunk locking screw on the bottom. So we lock it in so that the wheels just touch. So when the rod's at full extension, it's fully supported, and when it's all the way back in, the wheels are just touching on the plates. And these are the blocks. Now, this is, a few hundred grams compared to a giant four-wheel sled, which takes up a giant amount of space. This is no longer than your rod end. So this way, you don't have nothing's floating in front of your pulleys. You don't have a giant carriage up here. It makes for a much cleaner setup. There's nothing in the way. There's other ways we have our hard stops mounted. You'll notice I have aircraft pins here. These are 80,000 pound or 35, 40 ton pins in terms of shear strength. They'll hold these pretty well. And these clevises have been designed so that they hold the rocks with a little play. They're allowed to swivel, but they don't flop. Nothing here flops. You see that? So these are the things we do, the innovations we do here, because we'd rather work smarter, not harder. The problem with most rigging jobs is you're given gum and a crescent wrench and a hammer, and they expect you to use whatever crap is available to make it work. And the fact is, you usually can do something and make it work, but you just have to work your ass off to do it, and it never comes out right. Whereas if you have the right tools that are set up the right way, the right products, then everything becomes easy peasy, and you can worry about the result more than just how are you going to rig it. We make these compound heads here. Some of those people have 3, 4, 5 slots for pulleys. Well, we have a 3-slot head that connects to the clevis. You pull the pin and then attach this to your clevis, and your pulleys all attach here just like they attach here. So there's the extent of the head that goes on this, and this will hold 3 singles or 3 doubles. 3 doubles here, 3 doubles here, 12 to 1. Not that you're going to use that for a pull, but when you decel or use these as a braking device in the reverse fashion, it works quite nice. So you need more compounds. So it's 96 feet, 30 meters of run out you have with one of these. And we made it so the wheels are here, the shafts pull in and out. It becomes relatively simple. And that's how we roll, because that way we don't have to mess around. It's easier. Here's another iteration of a very slimline ratchet neck support. And you'll notice here's the adjustment screw. Here's the locking screw to lock it on the clevis. Minimalist, light. These are minimalist and light. I just have the sculpt them, they're a little wider. I go through various phases. These are a little bit blockier and chunkier, and some of them are super light. But it all depends on which run I've done and what I'm feeling at the moment. So that's what we've been busy here at Action Tech doing, building all this stuff currently. So we haven't done a whole lot of brake testing, and we haven't done a lot more after the ratchets. They were a bit exhausting going all through the ratchet theory, because I feel like I repeat myself a lot because it's a complicated thing. It's math and science, and most people don't care about physics. So right now, just wanted to check in with everybody who's been watching, say thank you to all the people that watch the videos and all the comments. And, we're going to be doing some more science soon. Once I get these out of here this week, and once all these pieces are finished being built, we'll be back to figuring out a new test protocol for something new, or maybe I'll go into just some actual rigging, though I think I'll save that for once we're back to work on stages. But I may discuss the theories of service loops and why we use them, which is always fun, because a lot of people don't use them. They have to just figure out how to re-rig something instead of allowing themselves the option of a service loop every time they rig. Couple other interesting topics, but anyway, that's us. Status, nice and easy. It's no big deal. Just want to say thanks to everybody for watching, and we'll clip in some footage explaining these that I did, and the rear plate, which is all handmade here. And if you look on Facebook and stuff, you'll see pictures of how we do things. We don't just make a simple punched hole bracket. We box the bracket in, we put a steel sleeve in the bracket, and we box weld the whole thing up and then put it onto the piece of equipment. Everything's done that way. It's not just an ear tab. A lot of these things you could probably just overdo by a giant hunk of U-channel steel on another giant chunk of steel, and it's inelegant, industrial, agricultural, and it's not really designed. It's thrown together. And we don't do that here. So we spend a lot of time on stuff that you can't even see in the final product. I'm especially thinking of the way these plates are done with the clevises, because they're quite precise, TIG welded together, machined on the lathe with inserts and spacers, and then all assembled, clamped and TIG welded, and then put onto the plates. Instead of just a random chunk of steel, an ear with a hole punched in it that has the right hole for the clevis pin, So anyway, that's us, and we'll talk to you soon on another Toolbox Talk. And here I haven't mounted it yet because it's on the other end and I need to get another corner cube. I was a little lazy. These are our end plates for mounting your ratchets. And here's the clevis. Now we could have just made 2 ears. We could have done 2 ears, which looks like a farmer built it. We could have put a 32 millimeter block of steel on there and welded it, but that's inelegant. So what we did here was we used 2 plates, and we put a steel sleeve in the middle and lipped it, and then welded it internally and externally, and then boxed the entire structure with 6 mil plate. So this is 8 mil and 6 mil with a steel sleeve insert that goes all the way through. And then it is welded to this. I mean, this is the difference between just a farmer building something. Could have just hung a piece of steel on there, whacked it on, but we don't do it that way. This is all bits and pieces, elegantly assembled. This plate is welded on this side as well as this side, and it's gusseted, as you'll notice. The clevis is lined up with the center triangulations. It's all triangulated through the plates, and the bolts hold it to the truss. You're never going to pull this off your truss. And this is the structure that holds the back end of your ram on the other end of this working system. So these we build here. Not many people have them. They are a true bitch to make. They take a lot of time. And with the lack of numbers, it's not like you can water jet them and change, because you have to change them. Everybody's truss is different. Everybody's center lines are different. So unless you know these things ahead of time, you have to set it all up and then work on calculating it all out and then machine it accordingly. So just the fit and finish, you'll notice it's all perfect. And that's what we strive to do here. Anybody can whack a few bits of channel and a piece of steel. I mean, if you want, you could be agricultural and put a 1/2-inch plate on the back of this and not gusset it, not do anything. But that looks like a farmer built it, and we don't do that here. So we gusset everything. It's all TIG and MIG welded. Depends on where we use it. The inner part of the clevis is all TIG'd, and then it's MIG'd to the plate. So that's what we do here. This is another one of the back ends on the ratchet mount that goes with our compounding and roller plates that you see behind me on the front. And this is how we can do compounding for decels, decelerators, as well as for ratchets, using the air cylinder. so it's always perfect and always on center lines. All right? Just a sample of the kind of work we do here. So here's a view of the plates that go on the end. We knurl the knobs. The shafts are plug and play removable. These are compounding heads because here it will hold either singles in every slot, or the slot also holds doubles. Your centers are all the same as for your ram. So you can compound in reverse however you like to for your ram. All the centers are the same on both. This will hold up to 3 of the rock singles or doubles. So with 3 doubles here and a compounding head that you could put on the other side, which would also hold 3, you can go up to 12 to 1. Right now I have just a single on there. The double will go in here as well. Just plug and play. You just take the pin out, put the new in, and you can switch to a double. Basically, it's set up for a 1 to 2 right now. The rope would come in through this slot, go up through this sheave, around the return sheave, and go back to your clutch or whatever else is mounted on your truss. Okay, so this is how this works. We make everything here in-house. The shafts, the rollers have double bearings on both sides. There's space, there's absolutely no play, you'll notice. These are a set we've made for a customer in steel, so they were able to be welded, as opposed to, this is a 12 millimeter shaft here, it can't pull through. The reliefs are all cut to fit rocks. This bolts to some special 289 millimeter truss, which is a standard. It bolts to a corner block. And yeah, everything is handmade, from the knobs for the plug and play to the rollers with double road bearings in each end. There's a row of bearings here and here, here and here, all machined on the lathe, 50 millimeter stock. It's center line, so the rope comes around. You can run a rope from here, or this normally sits about 200 mil off the floor if it's a 300 mil truss. So 300 mil, excuse me, it comes around the roller. So you can have 270 degrees of rope access from here all the way to here, to wherever you need to go up. So this allows you to come in from anywhere above you, even if it's slightly behind you, because you can come out to this angle here without ever touching this plate. So 270 degrees, and it'll compound to the ram. You see one of our ram support heads here, and they have a bolt on the bottom, which you can't really see right now, here, which allows this hole is oval and allows for 3 millimeters of up and down adjustment on this, because the skate wheels are never exact. So you always want to make sure you have contact with your center lines, and everything here is perfect. So this measurement stays perfect. So sometimes you need to move it up or down a millimeter, and it's set for that. So you just adjust it, fix it, it's done. So these are the plates we make. Everything's from scratch, in-house. All the center lines are calculated. All the sheaves fit. It's plug and play. And this is what we do, okay?